Hi guys, this is Mrs. Lyons. Today we're going to talk about the mole map, and we're going to talk about a new and improved mole map that we are going to use for this unit, stoichiometry. Okay, so our mole map now not only has just one substance in it, we now have two substances. Notice we've got substance A and substance B. Okay, so we need to know, how do we convert from one of these boxes to another? First of all, anytime we're converting from grams to moles or moles to grams, it's what we've done in the past. We're just going to use the molar mass. Okay, and we get the molar mass always from the periodic table. Okay, and we know that 1 mole of a substance is equal to its molar mass in grams. So we could say the same thing up here. Okay, we need the molar mass. I'm going to abbreviate from the periodic table. So if we wanted to go from moles of a substance B to grams of a substance B, we would do the exact same thing using that molar mass. The new step for us is this moles of A to moles of B. And when we want to convert from 1 mole of one substance to the moles of another substance, this is where we use that mole ratio that we've talked about in class. And the mole ratio comes from the coefficients in the balanced chemical equation. Okay. So we're always going to have to look at our chemical equation, make sure it's balanced, and those coefficients give us the mole ratio of substance A to substance B. So let's look at some examples and see how this actually works. Example 1 says, how many grams of hydrogen are needed to produce 3.6 moles of water? And I've got the reaction here. The first thing you should always do is check to see if your equation is balanced. In this case, it's not. So a quick look, we've got 2 oxygens here, only 1 here, so we need to put a coefficient of 2 there, a 2 there, and a 1 there to balance that equation. Now, the other thing that I want you to get used to when you're writing stoichiometry problems, when you're reading these problems, is just how to attack the problem. The first thing that you should look for is the number, okay? The number in the problem is always going to be your given, okay? And that's always going to be substance A on our mole map. All right, so in this case, our given is 3.6 moles of water. The second thing I want you to look for is look for the question word, how many, and whatever follows that is going to be our unknown. In this case, grams of hydrogen. That's going to be our unknown, and that's going to be our substance B. Okay, so we're starting with moles of substance A. Now I want to look at our mole map. Notice I've got our mole map just kind of abbreviated down here. Grams of A to moles of A to moles of B to grams of B. So if we look at our mole map, we're starting with moles of A. And we're looking for unknown is grams of substance B. Okay, so if you look at your mole map, we are going to be going 1, 2 steps. So I'm going to draw my truth table. And I'm going to put 2 steps on my truth table. I'm going to start my truth table with writing my known. So 3.6 moles of what? Water. H2O. Always over 1. Now, to figure out what goes into our truth table, the best way is to look at the mole map. Okay, we're starting with moles of A. What is the next step on the mole map? if you look, the next step is moles of B. So I'm going to put up here in this top box moles of B. I have to think about it. B is my unknown, so B up here is hydrogen. So I'm going to put moles of hydrogen up here. Now I need to know what goes up in this box. Again, it's the next step in the mole map. So in this case, it's going to be grams of substance B. B is my unknown, so grams of hydrogen. So if you look, the top of your truth table follows the mole map exactly. We've got moles of A, moles of B, grams of B. Now we just bring our units down. So down here we'll have moles of H2O. And then down here we'll have moles of H2. Now, notice something. I put in all of my units before I ever started trying to figure out what the numbers are. Okay? Because if you look at your units, that's a clue to what you should be doing as numbers. For example, here in this first part of my truth table, I've got moles of hydrogen to moles of water. That's a mole ratio. Okay, when I have 2 moles, moles of one thing to moles of another, I need to look at my coefficients of my balanced chemical equation. So in this case, moles of H2, my coefficient is 2. Moles of H2O, my coefficient is 2. In my next part of my truth table, I have grams of hydrogen over moles of hydrogen. When I have grams to moles, moles is always 1. Grams always comes from the periodic table. So I have to look up hydrogen. If I look, hydrogen is 1.01, but I have 2 of them, so I've got to add that together for a mass of 2.02. Now, if I plug this into my calculator, I will get, let's see, I'm going to take 3.6 times 2 times 2.02 divided by 2. And that gives me 7.23 if I round. And that's going to be grams of hydrogen. Okay, so there's that problem. Let's do another example. All right. The second example, how many moles of ammonia can be produced from the reaction of 2.1 grams of nitrogen? All right. Again, the first thing we need to do is balance this chemical equation. Hopefully you're a pro at this by now. Let's see, I'm going to put a 3 here, a 2 here, and that leaves me with a 1 there. Now, again, let's evaluate this problem. My given is the thing with the number by it. So 2.1, so I'm going to write given, and I'm going to remember that that's substance A. My A didn't work very well. Let's try that again. There we go. Given is substance A. So I'm starting, let's see, 2.1 grams of nitrogen. So I'm starting all the way over here on my mole map. What am I looking for? How many moles of ammonia? So moles of ammonia is my unknown. That's my substance B. So let's find that on my mole map. Moles of B. So again, I'm going 2 steps. So it'll be a 2-step problem. Let's set that up with our truth table. All right. We're always going to start out with our known up here, 2.1 grams of nitrogen. Notice I always put in the element or compound in here so that I can keep track of whether it's substance A or substance B. Now let's fill out my truth table. All right, I started with grams of A. The next step is moles of A. So I want moles. I know A is my given, so that's nitrogen. And then the next step in my mole map is moles of B. So I'm going to put moles. What was B? B is my unknown. B is ammonia. So I'm going to look at my chemical equation in case I don't know what ammonia is. I've got nitrogen, hydrogen. This over here must be ammonia, NH3. So moles of ammonia. Now all I have to do is bring my units down. So I'm going to bring down grams of N2. Then I'm going to bring down moles of N2. So my units always come down diagonally. All right. Now it's time to fill in some numbers. When I have moles over grams, that's when I'm looking for the molar mass. I know that 1 mole is equal to the molar mass. So I have to look up nitrogen on the periodic table. It's 14.01 times 2. So I have a mass of 28.02. And then here I have moles of ammonia over moles of N2. That's a mole ratio. Where do I get the mole ratio? You got it, from the coefficients of the balanced chemical equation. So if I want moles of NH3, I look up here, that's a 2. Moles of N2, the coefficient is 1. Now I need to plug this into my calculator and get an answer. Let's see. I'm going to take 2.1, I'm going to multiply across the top, so times 2. Then I'm going to divide by the bottom. Divided by 28.02 gives me an answer of 0.15. My units are going to be moles of NH3. All right, let's do one more example. Example 3. How many grams of sodium chloride are produced from the reaction of 15.2 grams of chlorine with excess sodium? Okay, well, before we get started picking that problem apart, let's balance this equation. We've got Cl2 here. So I need a 2 here, a 2 here, and a 1 here. Okay, so now I've got a balanced equation. Now, there's something in this question that sometimes throws people off. And this says, with excess sodium. Anytime you see that wording in an equation, what that means is there's plenty of sodium for the reaction to take place. We don't have to include it in any of our calculations, so you can just kind of ignore it. Okay, so let's go back to picking apart, finding our parts. Here's the number, 15 grams of chlorine, so that's our given. And chlorine is substance A. All right. I'm using G as in given, not grams, but this is grams of A. And then it's asking how many grams of sodium chloride. So this is my unknown. This is B. So look at what I'm doing. I'm going from grams of A all the way to grams of B in this problem. So it's going to be a 1, 2, 3-step problem. So let's see if we can get this to fit on my slide. 1, 2, 3 steps. So we're going to start with my known, 15.2 grams of Cl2, chlorine. All right. Now we have to figure out what goes in all of these spots in our truth table. Okay, so we started with grams of A. What's the next step in the mole map? The next step is moles of A. So that's what goes up top. Moles of A, which is Cl2. What's the next step in the mole map? Moles of B. So moles. What is B in this? B is our unknown, in this case, sodium chloride. And then finally, our last step in the mole map is grams of B, so grams of our unknown, sodium chloride. Now we just need to bring those units down diagonally. So we've got grams of chlorine, moles of chlorine, and moles of sodium chloride. So you see how I did that? I just took these units and I brought them down diagonally in every single case. Now for the numbers. When we have moles and grams, it comes from the periodic table. So 1 mole. We have to look up chlorine on the periodic table. It's 35.45. We've got 2 of them, so we need to multiply by 2. So let's see, 35.45 times 2 is 70.90. Alright. And then I have moles of sodium chloride to moles of chlorine. So I want to use the mole ratio from the coefficients from my balanced chemical equation. So if I look, I have 2 moles of sodium chloride, 1 mole of chlorine, okay? And then finally, this last one over here, moles and grams, I need the molar mass from the periodic table. So I've got sodium is 23, chlorine is 35.45, and then we get 58.45 grams. Okay, so now if I plug this into my calculator, I am going to find, let's see, I'm going to take 15.2, I'm going to multiply everything across the top, so times 2 times 58.45. Then I'm going to divide by the bottom, so I'm going to divide by 70.90. That gives me an answer of 25.06, and that, my units are grams of NaCl. And I ran out of room. Okay, so hopefully that's 3 examples of the types of problems you'll have. Hopefully that will give you a little help as you're going through these problems. I will see you in class and we'll work on this some more.